dafür. I have no idea. There seems to be no clear correlation between the first number and the rest. This is also so weird. The green one is the old method, and it just uses a single Bezier curve. Beginning of the Bezier curve is here and the end is there. And my new method uses a lot of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it is possible that it can't use less than 8, as in it just divides it by the whole interval by 2, and then again by 2, and then again by 2. So these are exactly on the orange lines every time. But even this one is divided, and this one too. Doesn't make any sense. So here plots the old one. This is a new one. So I guess this solve here creates them. By the way, they are on top of each other if I don't add this -1. So I added this just to move the green one a bit lower. But they look exactly the same. Trying to understand this X1 here. It's being used here too, however. Yeah, doesn't really matter, I guess. Okay, so that's the whole domain here. Oh, you can't see that. It runs horizontally, it runs from -20 to 20. guess that is just value here. So it is less. Oh yeah, right. The green one is drawn one lower. So this is 11.3, which looks about right. And then 12.3 is about here. So yes, it's the beginning of the function. Now what? Okay, so it's now doing minus 10. Why? This is minus 20. This is minus 20, so maybe x1 is just... Yeah, x1 is minus 10 for some reason. Still doing minus 20, I guess. Yeah, I think we're just calculating these things. So we should also be calculating the... So we calculated the T0 now, it's minus 20. And then we calculate at 0. And then we have again 2 at plus 20. And then finally we'll enter solve. So what I can do is step and then just immediately finish. That's the first one at 20. That was the last one. So now we do step, enter solve. Okay, now we calculate the tangent. We have the point here and the tangent here, just the point here and the point here and the tangent here. So we don't have the tangent in 2, which is now calculated. That would be the value at 0. And then we calculate a point at 3 and 1 and the tangent maybe, or just a point, I think. Point at T3, yeah. Or no, we need a point at 1. I already have that, sorry. Yep. Solve. So just call solve again. On the first half. And the second half. Yeah, okay. Step. Solve. Okay, so what I'm trying to do is we're having a cubic. I mean the red thing, red and green, is the same. It's just an offset of 1. Is a cubic, right? Perfect cubic. Let me try to get it all on the. Oh, there it is. So just a normal cubic. And I can't wrap my head around it anymore. Is this approachable? Is it perfectly approachable, a cubic with a cubic Bezier, or not? Looks like it. This is just a single Bezier curve, the green one. So yeah, I would say yes, because these are vectors, two-dimensional vectors. It's a constant vector. And the PT is a point, so also a vector, x, y. So this is 2 equations, and we can just make the x coordinate of this thing it'd be equal to 0 plus 1 times t plus 0 times something plus 0 times something. So x equals t. And then for the y coordinates, we fill in the y coordinates of these 4 vectors to get any cubic we want. Therefore, it is very, very, very strange that I would have any quadratic error at all at any point. I just really don't get it. Let's remove the -1 again here. They're really totally on top of each other. Yeah, let's just look at the first half here. And it's divided several times. Now it's divided here. I mean, it divides in 2 and then again in 2 and again in 2 and this one again. It just really often has been often rejected. Let's add some debug output to that. I'm calling solve here. That would be this solve, I think. So we have the distance squared is larger than reject is true. And if reject is true, then we don't return. And this solution is removed from result apparently, and then we split the thing in two. So we call it twice. Now, what happens if I never reject it? So I choose one. Theoretically, I would say that that should give me a very good curve anyway, because it should be, you know, the very first curve should already fit perfectly. And absolutely nobody understands why we still have a lot of squares. As if nothing happened. What the fuck? It is like I didn't even compile it. Oh, I'm too. And yeah, that indeed, that was exactly like doing nothing. Okay, so that looks like, yeah, this definitely does not fit at all. My red one is not on top of the green one, therefore we have a big quadratic error and therefore divides it in two. So that shifts the problem to the question, why is this not an exact match to begin with? Because we know it's possible. I'm having a really bad initial Bezier curve here. Looks like the tangent here is correct, but the tangent here is definitely not correct, and here it is not either. Looks like the tangent is like negative, maybe. Yeah, it looks like more horizontal than something else, but I don't think if we look at the tangent here, just going through P1. So it looks like the initial tangent here is wrong. Yeah. Aha. Okay. You need some debug output, I think. Let's print the tangent in each point. Let's see, so we call solve. I think it is this one. Let's add the out entering. So this is the tangent, T0, so I get to see it now already. What the heck? I can't print orientation. 8-string view. No, there's just some random operator that doesn't fit. Yeah. For debug purposes. I guess I'll add an inlined toString. What inline? Unless we have that. Okay, let's not inline it. String toString orientation. And then standard OStream reference operator. Standard OStream reference OS. Orientation. OS right to string orientation, and then return OS. This must be inlined, otherwise get collisions since this is the header. And I have to implement that thing in the .cxx file. So anything about orientation here? Just passing it. Let's add it to the top. Yeah, how do I do that normally? If I had a memory, then well, I could just continue typing, but no. I'll just have to look for other places where we have this stuff. Hopefully all of them are done correctly. Yep, that's how we do it. AI case return. Probably need this include. Having the feeling. And then it's actually just if def cw debug. Hello. To something like case return with a semicolon for each orientation, horizontal, vertical, and perpendicular. Horizontal, vertical, and it's an enum class, so you have to add a class name in front of it. And then here comes never reached trick. Okay. Now this one is not inside if def cw debug, so maybe I was a bit too enthusiastic about it. Why would I ever want to print an orientation though, if it's not for debugging purposes? There is a call, it's not the only one. The first one already calls it twice. Yeah, that's because we never, if the depth is 0, then we just call it twice anyway. So let's concentrate on the first one, which is the first half, from -20 till, oh, what is this? This is still from -20 to 20. No, this is it, I think. Yeah, this is from -20 to 0. And this is from 0 to 20, so we need this one. And then I have no clue which is the tangent. Let's have a look. So we get, this is the viewport, yeah, okay. It's from -20, -20 to 2020. And then we get the fraction, whatever that is, tolerance maybe, ish. I don't know, can't remember it. Orientation, vertical. So we just look at vertical deviations. Arrow is vertical. It is x coordinate is considered to be exact. And then the -20, -20, 0. And then the P0 is at -20, 12.33, yep. And the tangent is, drumroll, 1, minus 0.355345. Well, considering that the green one is correct, this is a vector pointing to x -1 and then a little bit down. So yeah, down. I would say this tangent is correct. So this point here, -20, 12 point something, that's this point, and then the tangent is pointing down. So that must be correct, it's this way. And then the next one is P2. Which is just a point in the middle. And that is -10, 15. Where did my graph go to? It's completely gone. What the hell? I have to click on this. It stopped, leaving main. Minus 10, minus 10, 15. So yeah, this P1 here is the P2. That would be this one. And then the next one is P4. I'm highlighting this, but it is it says P2. No, tangent, sorry. P2 was P1, so this one. And that is that point at 0. 0 and then 4,4.19. Yep, that's this one. 0 for something. And then we get another tangent. 1 minus 3. So here it goes down steep. That is correct. Looks like the input is correct. However, then from this, we call cubic from, with, as far as I can see, the correct tangent here. Tangent, that's correct tangent, and the other tangents, and then this is the point P1. So this cubic should already know, it should be constructed with the begin and end point, this point and that point, and now we are completing it by passing this tangent, that tangent, and the vector that has to go through this point. And then it comes up with the red curve, which is just wrong because it should go down. So yeah, apparently the cubic form is wrong. Let's put a breakpoint there. I think it's the first time it's called, being called. Bricky, run. Hello, WL. Cubic from. Next. There it is. Cubic Bezier curve implementation. Yeah. Difficult stuff ahead. Calculate derivatives. Bracket algorithm. Not trivial. I mean, what the hell is G to begin with? You see, you know, I have a bad memory. I wrote this several weeks ago, month ago, I don't know. And I can hardly remember it. Okay, I vaguely remember that I had this in my variable names. Yeah, I worked on this like a long time actually. But, and then I do something else for a few weeks and then it's gone. I can hardly remember that I worked on it. which pretty much sucks because turns out not to work. Yeah, very much suckage. Debug code that you wrote yourself, but you can't remember it anymore, and it has a bug. Well, don't tell me I didn't add shitloads of comments. So some comment here. Okay, queued from the tangents. Construct a Bezier curve defined by starting point P0 and endpoint P1. And it does go through those, so that worked. Initialize better constructor and tangents T0 and T1. And T1 also works. Everything works actually, except T0. So, Bezier curve parameterized with t can be written as 1 minus t to the power 3 times p0 plus 3 times 1 minus t squared times t times c0, and so on and so on. And of course this could be wrong already, but I don't think I probably copied it from somewhere, which is then correct. Let's see. Yeah, if t equals 0, then this is 0, and this is 0, and this is 0. So if t equals 0, this gives me p0, and if t equals 1, then this is all 0, so that gives me 1, p1. Hence, this is the begin and the end point. And these are the control points. The 3 is correct. So yeah, it makes sense, right? This formula looks correct. Where C0 is P0 plus Sx times T0. Yeah. The control points, these control points, if you have this formula, and then these control points are lay on the line through, although C0 lays on the line through P0 with the direction T0. So exactly that. By picking the control point like that, it's going to have a tangent T0 in P0. Likewise here. A plus and a minus might be wrong, but it is, doesn't really matter. This is some real value anyway. So by picking this, we do enforce that the tangents are taken into account correctly. Then furthermore, we're going to make the curve go through PG, which is that point in the middle, at t equals g. The g stands for gamma, it's just some random name. And we don't care what gamma is, as long as the curve goes through that. But the result is going to be that you get an Sx and an Sy, which might be negative. And if it's negative, then we have a problem, because we want this. This is a plus because you want to go into that direction. So if t increases, you want to go in the direction of t0. And if t is close to 1, and we increase it towards 1, then you are close to p1. And you want to move along t1, in the direction of t1 again. That's why this must be a minus. So yeah, I even agree now with the plus and the minus here. Which then indeed means that Sx and Sy must be positive. And if they are not positive, then you just don't have a solution. Let's visualize this stuff a little bit. We're calling this, and I can just draw a line through, so we can visually see what T0 is. Let's do that first. So this was called from I have no idea. Where was that? Let's go to here, and then go to the solve. And then look for the cubic form. Yeah, here. Damn it, I don't have my plot here. Yeah, both P0 and T0 are being passed even to this function. So we can go one back here and then draw the line here. What is this? That's actually something completely different. It's old. This one. Point vector something viewport tolerance orientation. So it's the T. The T must return a vector that is the tangent. That was wrong. So that's the T must be wrong. Just this thing. 1 comma derivative. That should be negative. Why is that not negative then? Alt just R. Yeah, okay, but it was negative. What is past is being negative here, so that works out. And I was going to draw a line there. I would rather be able to draw a line from anywhere, really. Maybe just do commit this and then just make some changes. Just pass the plot to all the functions, so I can draw from the internal stuff. It's not really something you want to commit though. Add. Yeah. I want to commit this, also not really. What is this? I don't know. Let's say yes. I don't know. What is this? First order. Yeah, some kind of work in progress. Just commit this. Okay. Get div is now not that much anymore. So let's see if I want to I need a lot of stuff. Maybe I should just prepare some kind of lambda. Okay, right now I just want to draw a line, I think. So we make a line, draw a line, which yeah, draw a line through a point usually. With a direction. Can I have a direction? Or a vector, it may be easier. It is a direction though. So I need to create a line, probably, before I can draw it. My line can be created from math line. What? Line style. This is draw line. Sorry, this is not math line. This is math line. A point and a direction. So it must be a direction. Can't. Okay. So we construct a thing from point and direction, but it is a vector, so we want to convert a vector to a direction. Probably also a math vector direction, just simply call direction. Now two directions on the row. Let's just call this the v of vector. Okay, now we have the line. Then how do we draw lines? Impossible, I would say. Now I have to create a line in advance, otherwise it will be destructed immediately, and then that doesn't work. I need something with a lifetime of this scope, like something like that. So I need actually a line here. It's a plot line. That's gonna be the lifetime thingy. Does the thing have a default constructor? So this is a namespace plot line. No default constructor. Unless this thing has a default constructor, which I doubt. Line. That's a default constructor. Perfect. Okay, so this base class constructor is inherited by the plot line here. So we have a default constructor. And then, yeah, afterwards we still have to assign it, because now it's just doing nothing, of course. So I don't have an assignment operator here, but you can just construct it. I mean, there is one generated by the compiler, but that will then only accept a line itself. So we can create a line here as before, as a temporary, and then we can assign it to the plot line. So this line should be using Cairo window. I'm not convinced that we are in that namespace, so probably not. But we're using namespace Cairo window. Okay, so by using line here, we get a little line in the namespace Cairo window, which is actually this one, which is just math line, which is used here. That should work. But yeah, now I did assign the right stuff to the plot line, but we still have to draw it. So you get something like plot dot add line, I think. Not create line, because it already exists, just add line. And that it takes the layer, the line style, line extent, the line piece. No, I want to draw a complete line. This is quick graph. Huh? What? Just the last one. Don't tell me this is the only add line. Add connector. line piece. It's called line piece. I want to have stuff for line. There's line. And there is an add line. And nobody knows why I didn't get that last time. Layer line style plot line. Layer line style plot line. Okay. I bet we can use the default line style. And this is the plot line. Okay, so add line, layer, default line style, plot line. This is called second layer here. Second layer. I like this one. And then plot line and plot and second layer, they all need to be used by reference, of course. Can't make a copy of them. So this thing now would, well, takes a point and a vector and then it draws a line, persistent even. So we're going to pass that now, well, let's just, because it's, you know, as first argument to solve. And it is something that doesn't return anything and takes these two. Let's see, I need my solve again. To find that back again. Which one was it? Not that one. Not that one. This one. I think it was this one. So that's then a standard function returning a void, taking that, being passed as our value reference, and it is called draw line. Yeah, no, you have to pass that to this one. Not sure why I would use our value reference though. Might as well pass it as a L value reference. Actually, even here. Right. Yeah, so we have to add this now also to this solve. Probably implemented right there. No. Hmm. No matching member function from call to solve. Bezier fitter. Yeah, we have to pause it. To draw a line. It's also passed recursively. Right, okay, so we added this one, the print set we entered here, and now we can call draw line. And with the point that we want to go through and the vector that we want to, in the direction of which. Maybe I should draw a half line. Otherwise we don't know which direction T0 goes into. Yeah. Could draw a vector. Could draw the vector itself actually. Instead of a line. Oh. Yeah, it's this is the line. Thickness of 2 because that's a default. And I mean it did. There is only one object, so every time it draws it again, it overrides the previous ones. We don't want that, right? We only want to draw this then when the x-coordinate of P0 is -20. I'm not interested in this last point. Maybe I should just draw vector. Do you have something like add vector? Nope. I have an add connector, that's what I should do then. Connector. This must be a connector then. Let's call it just T0. We want this to be P0 and T0. It's going to be called for every time, but yeah, I'll just ignore the other calls. So we do if P0 x equals -20, then we're interested in it. Then we do this. Otherwise, we do nothing. This now must be a connector. And then we need to construct a connector, which is done from 2 points. Can only make 2 points. Yeah, makes sense. The thing has a beginning and an end. So that is P0 then, and then here we have P0 plus T0 just to the end. And then, which one is it? I think this one. So if we just pause one, then that's the 2 shape, and the other one is probably not shown then. There's no error. Yeah. So we can use this one, and then we need open arrow. Yeah, that would be sufficient actually. Already. So try this one. But yeah, now we don't know what the length is, so might be completely off the window or something. No, okay. There it is. And it's not very big, but it's sufficient to see that it's actually tangent and in the correct direction. But we get this thing. Why? The weird thing is that I'm pretty sure I tested this. I mean, I was working on this and then I improved it by adding this bracket algorithm. So I was testing it. It worked. Why would it suddenly not work? It's really weird. Man, this is a nightmare that there is a bug in this. Yeah, I guess I have to go back to the basics, as in what program was I using to test all this? I see something here, maybe it is related to that. It gave me access to something apparently. And there's no test that's using it. This is it, isn't it? Yeah. This was my program that I used to develop that. And we have 2 points. And the third point, and the tangents. And that works perfectly, as you can see. It's really going in the direction of this tangent and going through that point. Then, I mean, going through all 3 points and the tangents are correct. So the other one is something like here, and a little bit negative. And they had a point here, and that was very steep. And then it had to go through a point here. Ah. Ah. Okay. It goes up. Okay. Okay. So what's going on then here? Why is it suddenly going up here instead of going in the direction of my tangent? Oh, because it's like that. It is going in the direction of the tangent. Okay, it is going in the direction of the tangent. It's just bending like crazy here. Super bendy. So that's probably what's going on in the other case as well. But why? I mean, we know that there is a solution. Man, this is so weird. This is the only solution. So really, yeah, okay. So it's what is gamma here? I think the gamma is the minimum of this curve. So around here now. Or is it crossing here? Crossing through 0. Right, I see, yeah. So this tries to minimize J, the jolt of the curve, aka the bending. I would say if it tries to minimize the overall bending, then it shouldn't like bend like 90 degrees in one point. Maybe that's just me. So we move this point here to, move it over the curve, as it were. Why does the curve even change if I do this? Doesn't make any sense. You see this diamond here, and that's the control point. So the tangent through P0 is, this thing is on the line through P0, which is in the direction of the tangent here. And also if I put this thing up here so that it looks like it goes up here, it looks like the angle is wrong. You see that the control point is still on this line. So it's just bending like crazy here. I think that's what's going on. And that can be seen at the very least as well if I would draw the control point, which is what's this one here? Yeah. So I want to draw the control point of the red curve, which is probably still just here. It's just bending like crazy here. I think that's what's going on. So everything actually works, except that it doesn't do what I want. The result back is still the cubic, and we want to have the control point. Something like that. Result is a Bezier fit. No, what? Yeah. It's a Bezier curve. And that has a control point C0. I don't want to change everything, so just pass a vector, some vector. It's V0. Doesn't get highlighted. I have a V0 here though. No, just draw a connector still. Draw connector from P0 to. Do I have even P0? I don't have P0, of course. Very annoying. No, just do the same thing. Wait a minute. Yeah, I can do this though. So I have to pass P0 and then T0 such that we arrive at C0 to make it work. That's C0 minus P0 then. Veld operand zo binary expression vector and point. Oh, C0 is a vector. What the hell? Why? Convert it to a point. This point. No, I should have done this earlier. What the hell? You can see that it does work. Except in stuff like this, then just my control point is not being drawn. So there's no vector at all, actually. Say I'm happy with this. Look at this shit. The green one proves that it is completely possible, and then I get this kind of this shit. This talk. I think the reason is that it's this one is optimized between fat quotes to have as little curvature as possible. So this one has a strong curvature here, and this one looks almost like a circle. It's like, oh, you want me to go from here to there? While going through this point. It's not even doing that now. What the hell? It works here. It's in a small region of where P1 can be. PLB, and then deviations like crazy. Man. And then the stupid thing that it doesn't care about direction, or it decides itself the direction, which direction to go. The tangent is the same, but the direction is wrong. It must enter from this side. Surely there should be a way to minimize the curvature under the restriction that the direction must be the same, in which case we would exactly get this curve. Well, I'm pretty sure of it. I think that's the whole problem here. If I would be able to find the curve where the direction is correct, the tangents are, well, no, maybe not. Let me put this back. No, you lost our capability to drag stuff. So this is clearly going in the right direction. But still there's an enormous deviation here. And the reason is that it tries to minimize the curvature for some reason. Overall. But then what about the curvature here? Yeah, I think it's time to quit again. Gonna play some chess. Oh man. $2,128. Seriously? Yep. They know how to play it. But not staking my pawn. Interesting. Hmm. If now develop the knight, I block my queen, so they can safely take here. Black is way better now. Can't give away this thing though. True that. Yeah. Huh? Nou ja. Yeah, black is better here. Just have to push the pawn. I can't even go to this file with my queen. Okay, do this attempt here, and then if he would take back, I would have be winning. But they could do, yeah, well, maybe it's hard. The queen is attacked, so threaten another queen exchange here. Which is quite annoying. They would have to go here, but I can't. I mean, I can't even threaten to go here. Stupid. I feel like I want to defend my bishop, and then he just takes my knight. So I now stand on this diagonal. Probably also not very good. What happens? The ticket. Pushing my queen away from the diagonal. Well, now I can threaten this. Computer knows all. Oh, my knight is here instead of here. Yeah. Move, not enough. 8 in 3. Yeah, well, okay. Computers always win. Shall I go here? I think I will. So, now I lose this pawn. Kind of looks like it. Yeah, so knight takes here and then goes there. I can just take it then. Or maybe you should do this, take en passant and get an open file here. Yeah, I got to develop, right? Push this pawn maybe, put the bishop on this diagonal, which he's gonna open. Let's try that. I'm threatening to take this pawn, get my pawn back. What the hell is a knight doing there? You want to go here or something? Or something. Oh, good check here and then have to go back. That's not the best move. It was not the best move. Doesn't do it. I'm happy. So it defends the bishop. Huh? Yeah, it's a bad bishop. Let's not take it. I want to maybe just move this thing back. Then this thing goes there. Nah. Go here maybe. Oh, and the bishop is gone. Oh, really? Why? Oh, he doesn't see it. Good. Okay. Could have played this pawn and no squares left. Oh, lose this pawn now. Not that bad. Not that bad. Can leave it that. Yeah, I'm 2 pawns down. It's maybe a bit much though. 20, a little bit much. Harsh all in one. Bezier curves. Yeah. A good drawing. I have to concentrate on chess though. Yeah, I studied Bezier curves for many months. And if I had a good memory, then I would be an expert in Bezier curves by now. But I'm afraid that the only thing that I know is what is in the comments of my source code. Everything is free. So this guy, 2067, and he plays like this. What happened? I think he was exploding. His mind was exploding. Well, you can download my source code and then look at the comments. So for a start, the repository is over here. And then all Bezier stuff is in Cairo window, I think. Which is a Git submodule. You could look at Bezier Curve.h and .cxx, for example. And I have maybe a README about it. No. See, there's stuff to read here. This is a Bezier curve, and you can write it in different forms, like this, or work it out and then get that. Now you have the first and second derivative, obviously. Third derivative is just a constant. And then my class is doing about everything you can do with the Bezier curve. So you can this one creates the begin and end point, and then afterwards you have to call one of the from things, which, like, for example, a linear from, what's the other, quadratic from, cubic from, so a lot of quadratic froms, cubic from. So all these from things are called after constructing it with just passing the begin and end point. And then the standard way, you pass begin and end point and 2 control points. You can pass it as point or as vector. This is just a type difference. I'm not storing the begin and end point and the control points. So most people do that, I guess, but I'm storing it as a matrix of these values. But yeah, I mean, it's just a mathematical difference. I mean, it's not really a difference, just almost a notation difference. Right. Yeah, I also have a picture here, I think. Or there's a test, probably. But that's just, I think it's just a quadratic one. This one. Yeah, it's a quadratic Bezier, so where j equals 0 to the null vector. Then the quadratic Bezier is actually just a parabola which is rotated. So normally a parabola is standing right up, of course. And this is a parabola that can also be under an angle, being rotated. And if you're interested in quadratic Beziers, then I have a README somewhere which goes into all the details how to derive these things. Like V is the vertex of the parabola. And then if you go one in, so if you I've defined an x and a y axis, just like you would do for a normal parabola. Yeah, so the symmetry line of the parabola is the y-axis here, and then perpendicular to that the x-axis. And then one high, that is gives the w, the width of the parabola. And then the begin and end point, P0 and P1 here, they lay on a circle. Where P0 is the point that you get when you fill in t equals 0, and P1 is the point that you get for t equals 1. Yeah, and then S is defined by how wide this part is compared to the width here, and then this length is, well, it's just Pythagoras, I guess. So this thing also given. I have a program that shows this, I think, interactive, so you can just drag stuff around a little bit. And that's way more informative, actually. But the hard part, I think, of Bezier curves is where you have some data points and you want to draw a curve using Bezier curves. So then which Bezier curves to use to fit data points, that's definitely the hardest part. And I'm still working on fitting good Bezier curves through a function. So if you know the function and the derivative even, then yeah, you can also approximate the function with piecewise Bezier curves. But yeah, also not easy. Those are the hard things. Very hard, I would say. Normal is you take the knight and then you take the pawn. But at some point I played against Stockfish and it just let the tension exist. And I've been trying that ever since, but I forgot what to... And we have to analyze this game afterwards, really, we do. I think I'm gonna play this and then hopefully see what Stockfish thinks about the position. That would also play this, or I don't know, or if maybe it's wrong and this exact position I have to take. Yeah, it's kind of lame, I think, but Yeah. My queen is attacked and the bishop, so I have to take. So now this bishop has to go, I think, from this diagonal. You could put it here, defending the queen, or has to play this pawn. But then I play this pawn, and he has to go there anyway. So yeah, maybe not. I could first spin my pawn then, but then I just take the bishop with my queen. No, of course not. So he plays this pawn. I play the pawn, then the queen comes here. But I think with this pawn here, I could have a check here. So if I just play the queen here, I'm threatened to give mate in two. I don't know. I have my doubts about this position for black. Yep, he goes there immediately. That's probably better, otherwise I would have had this check and stuff. But okay. I still have this one as well. Looks undefendable. I go here and flatten mate in one. You can give check. Oh, the bloody hell, he gives check with the bishop and then takes my knight. And this bishop is coming. It's not good. Okay, suppose I put my rook here, so he can't play the bishop here. And he plays this bishop, pinning the knight, and I play the knight here anyway, and he takes my rook, threatening mate. Then I give mate. So the knight is here, I've threatened mate in one. If the rook moves, I just give check and mate. The pawn moves mate. There's absolutely nothing you can do. Gotta try this. So another threat is again, the knight goes here and the unstoppable mate. Yeah, he has a serious problem. Yeah, that's kind of like the only move. No, I would like to put my rook here, which is not possible. Pawn, maybe? Nah. This one, too slow. Let's go here, just to gain a tempo or something. Unprotected rook. Yeah, this deck here, I guess. No, I can't put my rook here. It threatens something. He doesn't have check. But he does have this rook, just defends it. He's kind of annoying. Yeah, that one is attacked. Let's put it here. I don't think I have an attack now. Damn it. To walk with this pawn is probably better. I think I'm gonna put this rook over here. Possible. But he's probably going to develop this rook here. And then I'm not sure if this is the best. Get a pawn here. Yeah, but what else can I do? Just do it. Oh, no. Yeah, I had not seen that one. How did I miss that? Oh, my rook was the one stopping that. Yeah, so that was a very stupid move. It would have been better to play the other one. The other rook. Black is way better here already. Yeah, so in this position, okay, that's theory, and I should take apparently. I should take, and I did. It's minus 0.2, and I did this. Well, yeah, well, yeah, minus a half. Oh, that's bad. Oh, I should not do that. Castle, and then he just takes it. Yep. Yeah, I lost a piece there. that was bad as well. Should attack with the queen. Why did it find that move? And now developed a rook. Did not develop my rook. -3. Double question mark. Yeah, and I hoped he would do that. Because then I went here and I thought I would win that. Huh? What? So I thought, and now I know I'm just. Oh, he's. Oh no! Oh! Wow! Brilliant! Yeah. My rook had the purpose of sacrificing itself on this bishop here, but it now was overloaded with blocking the bishop as well. So now I can't take, which means I lose the rook. Lose the. Oh, I'm in check. So yeah. Yeah, that's horrible. Okay. Nice combination. So is that worth 2 question marks? If you want it is this deep, this complex. Okay, I'm going to stop streaming. Be back tomorrow.